All right, this is the intro video for Calculus BC, section 3.2. And in section 3.2, we're going to be talking about the MVT, also known as the mean value theorem. So we're just going to jump right in here. The mean value theorem is stated right here. If f is continuous on a closed interval and differentiable on the open interval from a to b, then there exists at least one number c in the open interval such that this is true. So we're going to break this down a little bit. F prime of c, that would be, of course, the derivative of f evaluated at c. So I'm going to say something like the slope at x equals c. So the slope of maybe some curve when x is equal to c. And then the right side, maybe you recognize this as the old school slope from way back, the difference quotient. This is the average slope on the interval from a to b. So a different way to think about it, maybe a little bit simpler, if f is continuous and differentiable, then somewhere the instantaneous slope equals the average slope. And I think a picture is very helpful here. If we were to take a look at a graph like this, it looks like our interval, looks like this is, let's see here, looks like this is -5 over here, and this would be a 1 over here. So if I were to try to illustrate this, we could do this with a picture. We could also do it with some numbers as well. I think we'll probably do both here. What I'm going to do is I'm going to draw in a line segment that represents the average slope, and I'll try to do this one time. That's pretty good. So that line right there represents the average slope. I mean, you can see that we've got rise over run, and that slope of that line segment I've drawn in there would represent the rise over the run pretty well, I think. Okay, so we got that as our average slope. Now, what the mean value theorem says is that as long as this function is continuous and differentiable on our interval here, then this function has to have that exact same slope at some point along the way, at least once, maybe more than once. And so from a graphical perspective, I would say that we could draw a tangent line parallel to that average slope. Yeah, somewhere in there. I'll try to neaten that up a little bit. That's not very good. Something like that. Think about it for a second. Do you see any more places where you would see a tangent line that has the same slope as that secant line, as that average slope? Hopefully, maybe you're looking like right in, well, let's try that again. Maybe you're looking like right in there. How about there? I'll try one more time. Nope, I'm going to try 2 more times. There we go. I'd say that right there, that point slightly to the left of -2. Again, we've got an instantaneous slope that's roughly equal to that average slope, and then maybe one more down here, something like that. So I'm seeing 3 different spots where the instantaneous slope is the same as the average slope. Or the way you could say it, I said it earlier, you could say where the slope of the tangent line is the same as the slope of the secant line. And so the mean value theorem simply guarantees the existence of those points. The conditions for that, of course, like I mentioned earlier, f has to be continuous on the closed interval, differentiable on the open interval in order for that to be true. So that's the mean value theorem in a nutshell. We will do a couple of practice questions when I see you next time in class.